Hi everybody. All right, we're going to continue with some Chapter 9 problems, and here goes. A structural beam is 10 meters long, has a mass of 250 kilograms. It's supported by two columns, column A and column B. Three pieces of machinery are sitting on the beam as shown in the diagram. What force upward is exerted by column A and column B? This is a sum the torque problem. Now, it might not obviously feel like a sum the torque problem, but we have a static situation. When you have a static situation, that means the sum of the forces are going to equal 0, and that also means the sum of the torques are going to equal 0. So we're going to have a normal force up. I'm going to have a normal force up caused by A, and I'm going to have a normal force up caused by B. And I've got to figure both of those out. This is very similar to the window washer problem we did earlier. It's just a little bit more involved. If you have a situation that's complicated like this and you have two unknowns, it is wise to put your fulcrum, your axis of rotation, underneath one of your unknowns so that it falls out of the equation to make your life a little easier. So I am going to choose to put my axis of rotation underneath my A right here on this end, just to make the math a little bit easier. And I'm going to do this in red because I don't want it to get lost in the blue. Before I do this, there's one more thing that I have to look out for, and that is we're given the weight of the actual beam itself. Now, the weight of something is going to be, if it is symmetrical, the weight is going to apply at the geometric center. So the force of gravity of that beam is going to be its mass times the acceleration of gravity, 250 kilograms times 9.8 meters per second squared. So the weight of that beam is going to be 2,450 newtons. The whole beam is 10 meters long, so 5 meters from this end, so right around here on my picture, I'm going to have a force vector down of 2,450 newtons, and that is going to be 5 meters from this end. So that is also part of the weight that has to be supported by column A and B. Now, big idea, as always, is the sum of the torques up have to be equal to the sum of the torques down. So the sum of the torques that are going to make this rotate up are going to be equivalent to the sum of the torques that are going to make the whole system rotate downward. Or, if you want to say it another way, the sum of the torques that are going to make it rotate counterclockwise are going to be equal to the sum of the torques that are going to make it rotate clockwise. So instead of drawing arrows, because I think there's enough arrows, I'm going to just do this with color, I think. What's going to be a torque? If I put my fulcrum here, my pivot, my axis of rotation right here, what is going to make it rotate upward or counterclockwise? Well, there is only one force that's going to do that, and that is force B, the support force, the normal force caused by B. Force A is going to fall out of the equation because any force perpendicular to an axis of rotation will fall out of the equation and not produce a torque. So that's not going to produce a torque, and it's one of the reasons we put the axis of rotation over that pivot. Okay, so that's going to go up. These, the 2,200 newtons, 3,100 newtons, the weight of the beam, and this 4,300 newtons, all of those are going to make it rotate down or clockwise. So the force up, the torques up are going to equal the torques down, and now we're ready to create our sum the torque equation. So here goes. My torque up is going to be the force, normal force from column B, times the lever arm. Well, what's the lever arm? The entire beam, we're told, is 10 meters long. So times 10 meters. That is going to be equal to each one of these torques on the beam. So I'm going to start going from left to right. Force of A is through the pivot, does not cause a torque. Next one I come to is 4,300 newtons, and it is 2 meters over. Meters, all right, plus 3,100 newtons, and it is how much total from the pivot? 2 plus 4, it is 6 meters over. You know what I forgot? Yeah, I know, I blasted right past the weight of the beam, so let's add it in now. Plus the weight of the beam, this vector down, is going to be 2,450 newtons, and it is in the geometric center, so 5 meters over. Plus, and I wrote too big, so I've got to keep going. I already did my 3,100, did my weight. Next one is the 2,200. 2,200 newtons times, okay, the entire beam is 10 meters. I'm 1 from the left, so the distance from here to the axis of rotation is 9 meters. Now, all I have to do is mathematically simplify this. So, force upward of beam B is 10 meters. 2 times 43 is 8,600 newton meters. 31 times 6, 31 times 6, oh boy, I gotta grab a calculator. I was trying to be show-offy and do it in my head. Don't do that. Oops, that's a plus sign. So this is going to be 18,600 newton meters. 2,450 times 5, this is going to be 12,250 newton meters, plus 2,200 times 9 plus 19,800 newton meters. Okay, I'm going to add up all 4 of those. So 19,800 plus 12,250 plus 18,600 plus 8,600. I get the whole entire left side, 59,250. Is that what you got? I hope so. Okay, that's the force upward caused by beam B. And if I want to know what that force is going to be, I am now going to divide that by 10. Divide by 10. That's a comma, not a decimal. So force upward by B, I got 5,925 newtons. Second part of the problem is, what is the force caused by the other beam? Well, then we go back to Newton's law. And Newton's, I'm going to erase a little bit up here because it's just as simple doing it here where we can see what's going on. Newton's first law says in order for an object to be stable or not moving, the sum of the forces on it have to equal 0. So in this case, the sum of the forces up are going to equal the sum of the forces down. And my up forces are going to be force A plus force B are going to be equal to all my forces down. Well, all my forces down are 43 plus 31 plus 22 plus 2,450. And when I add all of those together, I got 12,050 newtons. And that's going to be equal to force A plus force B. And force B was 5,925 newtons. When I do a little fabulous math, I got force A equals 6,125 newtons by subtraction. All right? All right. We'll see you later.